Okay, let's walk through building the optimal risky portfolio. Let me show you the data that we have. We have the 9 different sectors from the S&P 500, and here is data from Ken French's website with the different factors and the risk-free rate that we're going to need later on. This data goes from 2005 to 2009. So let's pretend that it's the first day of 2010. We have all of this data available to us to come up with the optimal risky portfolio. Okay, so the first thing we need to construct the optimal risky portfolio, using, in this case, historical data only, we need to have the covariance matrix. Okay, in order to do that, spell covariance matrix correctly, I need to go to Data, Data Analysis, come up here to Covariance, click OK. I might have labels in the first row, and my input range have all my different assets, so I have labels in the first row, so highlight those, go all the way down, all the available historical data. Output range, we can show exactly where we want to have the output, so let's put the output right there, click OK, and there is our covariance matrix. But we need to flip this thing over. We need to have the whole thing filled out, so copy, paste, and now you can highlight this, copy, click right here, paste special, transpose, values, skip blanks. The values keep this underline from showing up. Okay, there we have it. Let me clear this out and get rid of that underline that I don't want. And there's our covariance matrix. Next, we need to have returns. And let me just clean this up a little bit. Do merge and center, bold, italics, underline. Now we know our covariance matrix. Alright, so the returns, we want to have returns for all of these. And right here I don't want to have that. So what I need to do is go to the bottom here, control down. By the way, I did view freeze top row, so view freeze panes, freeze that top row. So when I go down I can see what my column headings are. So just equal average, period, control up, copy that all the way across. Okay, that's exactly 0. That's kind of unusual. Control up, and right here highlight all of this. I want to have those returns, so equal transpose, come down here, control down, highlight all of this, and now give it a parenthesis, control shift enter at the same time, and we have all of those returns. Let's format those, and those, remember, are monthly returns. So we have a monthly covariance matrix and we have monthly expected returns. We do that, that's going to be just fine. So let me make sure this is labeled. I'm going to give another row here. So this is the asset, this is the return, and then I can find the weights of the optimal risky portfolio. In order to do that, let me get these looking good, I need to have the risk-free rate. So this number I'm going to put in here is 0.01, make that 1%. And let me tell you one of the differences here. What I'm trying to do is use what the covariance matrix was to predict what it will be. Use what the returns were to predict what they will be. I don't need to look at what the risk-free rate was to predict what it will be. I know what it will be because I can look it up. It's 1%. I should have that put in monthly terms. So divide by 12. So my monthly return is going to be a very small number there. Okay, so now I have all the inputs necessary. And for the weights, what I do is equal matrix mult, matrix inverse. I take the inverse of the covariance matrix, and I multiply that times the returns minus the risk-free rate. And right now I like to do Control-Shift-Enter. I'm getting numbers. Okay, that's what I want to know. At least I put that in correctly. Now I can divide by the sum of everything that was on top. Copy, paste, give it a parenthesis, Control-Shift-Enter, and let's get those formatted. We can do those in percent. Alt equal, we'll sum it up, sums to 100%. That's what we have. Okay, so now these are going to be the weights, and what we need to have going forward are to build the actual portfolio. So I have data here. Oh, that's the wrong data. I gotta get the right data for this. So hang on just a second. Let me pause this. Okay, now I have the right data. So beginning in 2010, these are the returns from the different sectors. So over here I've decided that my weights are going to be this, and I can copy these over. Let me do it this way. I'll say the weights I chose, I'll just put them over here, weights is equal and I need to make sure I have them labeled right. Here's this, just copy this over. So there are the weights for my portfolio. So now I can determine what that portfolio is. So let's call this history port. Make that a little bigger. And so the way we do this is we want to multiply the return for XLB times the weight for XLB plus return for XLE times the weight for XLE. So the way we do that is equal matrix mult, and we have this is 1 by 9, comma 9 by 1, but that's never changing. So F4, Control-Shift-Enter, double click this, and they have that go all the way down. So now we know the returns, the monthly returns that this portfolio produces is given right here. Right, hang on a second, and interrupted. Let me pause. Okay, so here are the returns I have for the portfolio, and I need to go down and get some stats about this. I need to have the average return. I need to have the volatility. I need to have beta. So let's go ahead and do that. Equal average. Period, control up. That's the average of it. Sigma equal standard deviation. Period, control up. That's the standard deviation. So given that, I can find the Sharpe ratio. Sharpe is going to be the average divided by the sigma. Let me get some formatting here to make this look a little bit better. In order, oops, I didn't want to do that. I need to have the beta. So in order to do beta, I need to have the market. Oh, and I forgot one thing actually. These are historical returns, but I have not subtracted the risk-free rate. So I need historical returns minus the risk-free rate, right? Because in order to get the Sharpe ratio, that's what I need. So let me pull up the data that I need to do that. Be right back. Okay, so I forgot to subtract out the risk-free rate. So what I've done here, I picked up the Farmer French data for the dates that match and that I don't need. These are the dates that match from 2009 to 2012. So the returns for the portfolio are the weights. This is return above the risk-free rate. So the weights times the returns minus the risk-free rate. And this is what the risk-free rate was January 2010. This is what it was February 2010. See how close it is to zero? That's because the Fed had rates so low. So it doesn't really make much difference. But at the end here I have the average, the standard deviation, and the Sharpe ratio. Now I need to get the beta. The beta is just going to be the slope, where this is the Y, the returns in my portfolio, or the Y. Notice I have the risk-free rate subtracted, and this market returns that Ken French has are the market returns minus the risk-free rate. So that's why we have to be consistent. See the MKTRF, this returns minus the risk-free rate. So there's the beta. So I can find the trainer measure by having the beta divided, by having the average divided by the beta. Okay, next I need to have Jensen's alpha. Let's have Jensen's A. I can do that two ways. I can type equal intercept, and I can do the same thing where this is the Y and this is the X, and that's my alpha. And I really would like to annualize that, so that times 12, that gives me some sense about what that alpha is. But to really know if that's significant, I need to run a regression. So I go to data, I go to data analysis, I go to the regression, click OK. My Y range is right here, and I'm going to have labels in the first row. So I'm going to click this thing that have labels, and my X range is the market, and it's going to ask me for an output range. So let's put it right there, and let's give it a little better formatting. And we can see the intercept there is the same as the alpha there. So that's Jensen's alpha. Next I need the Fama-French alpha. I'm calling it Fama-French, but it's a little more than that. So I'm going to use for my X the market return, small minus big, high minus low, and the momentum. So to run that, I go to the data analysis, run the regression. It's the same regression except for X I have all four of these. And I just need to change my output range so I don't lose that data. Click OK. Let me give that some numbers here. Okay, so what I have at this point is, note my p-value here. If the p-value is not less than 0.1, that's not really significant. So really the alpha, well, that's close to zero. You didn't beat the market. You didn't have more return for the risks that you took. And all I've done here for the Fama-French alpha, which by the way will be this number, is this is the amount of extra return I got for the risk I took. And I'm measuring risk by 4 different proxies, not just by 3. So this makes this a better measure of what's going on. And the p-value is larger here, so you didn't beat them. You didn't outperform. You didn't get more return than you should have given the risk that you took. Okay, so that's the first way to come up with historical returns. Let's say that you have a benchmark. So let me insert a row here, or insert a column, excuse me. I'm going to put your benchmark right here. The benchmark can be whatever it's determined to be. Let's make it equally weighted. So equally weighted, I just have the average of all of these. and I subtract the risk-free rate. So I said forget about doing any of this fancy math. Let's just put the same amount in each one of them. There's the average, that's your benchmark, and now what I'm going to do to test you is I'm going to have the historical return minus the benchmark. So equal this minus that. And now I can do the same test where I'm going to run, I'll just run the one regression here. So data analysis, regression, and the Y range is going to be, make sure I get all of these. It's going to be those. By the way, I don't have a lot of data here, so that's one problem. Since I only have 36 returns, it's not going to really give me much of a chance of having historical significance. We really need more than that, but you know, this is just to make sure you understand the mechanics. Okay. So click OK, and let me highlight all of this so we can look at this a little bit better. Alright, so what do we have here? I have the returns that you got minus your benchmark, so you would want those to be positive. Let me look at this over here. You would want each one of these numbers to be positive, right? And that means you're winning. If they're negative, that means you're losing. So what I can do is I will look at that intercept. If this intercept is positive, that means you had a greater return than your benchmark did. So you want that number to be positive. You also want the p-value to be low. You didn't outperform your benchmark. And all these negative numbers, it looks like you took different levels of risk too. So if I told you in this benchmark, here's the style of investing you should have about this level of market risk, about this level of size, value, and momentum risk. These numbers theoretically then would be 0, and they're not. So you didn't take the type of risk that I told you to take, and you didn't really beat the market. So you know, you're fired, I guess. So that is the evaluation. Doesn't matter what the portfolio is, it'll be the same setup. The only difference is when you do the portfolio, how do you form those weights? How do you come up with these weights right here? There are 5 ways to do it. Gut feel, do it equally weighted, so those two, you know, not mathematical at all. Then I could use the historic covariance matrix and returns. So my covariance matrix and returns right here could come from history, and my returns come from history. Or I could have the single index model to produce this covariance matrix, and I could use a single index model to produce those returns, and hopefully that would be better. Or I could do the Black-Litterman approach. So I will show you in another video doing the Black-Litterman approach to get those weights, and we'll leave it there.